Welcome to the Crazy Hat Chemist. So today we're going to be doing the 14th video in electrons and atoms. Bam! So today we're going to be talking about atomic orbital shapes, specifically the S-type shape of an orbital. Okay? And here is three different orbitals of S-type. There's a 1s orbital. That's that central blue sphere that's in the middle. Then we have the gray sphere, and that's a 2s orbital. And then we have the blue outermost sphere, and that's a 3s orbital. There's a 4s orbital, and a 5s, and a 6s, and a 7s, but those are not shown here on this diagram. You should see as the principal quantum number, n of 1, n of 2, n of 3, as the principal quantum number n of 1, 2, and 3 increase, you get farther from the nucleus. That's very critical. This diagram, that little blue and gray diagram, is like taking a sphere and slicing it down the exact middle so you cut it in half. And now you're looking at it on end. Okay? This diagram here on the bottom, okay, there's a lot of stuff here on this diagram, but on the far left-hand side, we're going to focus in on that. And in the middle. So in the middle, S-type orbitals are spherical. So just as a quick little reminder. Okay, look at that left-hand diagram there. And you see a bunch of dots. This is an electron density map. Okay, or an electron dot map. So it's an electron density map. There's a 0% probability of finding the electron in the nucleus. That's actually called a node. That is a 0% probability of finding the electron anywhere is a node. You cannot find the electron in the nucleus, that's for sure. Okay? The electron probability decreases as one moves from the nucleus until eventually that electron is completely removed, and then you can't find the electron in that atom, and that's why it's a 0% probability of finding it. So you should see at that left-hand diagram that is green there, there's a bunch of dots, and you should see that it's very dense near the middle, and then it slowly dissipates out. Okay, so as it slowly dissipates out, then there's a less and less and less of a chance of finding that electron. That's why there's fewer dots there. Okay, so that's why our orbital is defined as 90% with an electron density map. Okay, now I want you to look at that far right-hand diagram where you see that graphic with the three little humps there. So that first hump there is a 1s orbital. Okay, and that second hump is the 2s orbital. The third hump is the 3s orbital. So that's the density of those electrons in those types of orbitals. The 1s, the 2s, the 3s. Okay, now we're going to talk about some nodes yet again. A node is a 0% probability of finding the electron. Now, we can't find the electron in the nucleus. That's a node. However, we're now going to be talking about planar nodes. Okay, planar nodes are equivalent to the L value. The L value for an S-type orbital is 0. Since the L value is 0, that tells you how many planar nodes are there. Since the L is 0, then there are 0 planar nodes. Okay? However, there are nodes in between orbitals. Okay? So you can't find an electron in the nucleus, nor can you find an electron in between the orbitals. So I want you to look again on that far right-hand graphic where I have the 1s, the 2s, the 3s that's green, the graph that's in the green on the far right-hand side. Okay, now you should see that there's a graph and then there's a dip. In that dip is going to be, so that first dip is actually not seen, but that's on the left-hand side. That's the nucleus. You can't find an electron in the nucleus. That second dip that's in between the 1s and the 2s is going to be one of the nodes. So you can't find an electron in between orbitals. That is not a planar node. But you can't find the electron in between the 1s and the 2s orbital. Neither can you find an electron in between the 2s and the 3s orbital. I want you to go back and think about the ladder in which we drew out before in an earlier lecture. You cannot find the electron in between the rungs of the ladder. You can only find the electron at the rungs of the ladder. Okay, that's a critical understanding. even in the Niels Bohr model, and now even at this moment in time. Those are nodes. 0% probability of finding that electron. Here's another diagram. The far left-hand side of this diagram, I see just a blue sphere. That's a 1s orbital, and you can see that graphic down below it, and that has the electron density there. Okay? The next sphere is the blue sphere in the middle, that's the 1s, and then the pinkish sphere around it, and that is a 2s orbital. And you should see that graphic down below there as well. Then you should see in the far right-hand set of spheres, the blue sphere in the middle, that's the 1s, then the red sphere surrounding that, that's the 2s, and then the big blue sphere, and that is the 3s orbital. Okay? In between these spheres, we have nodes, and that is a 0% probability of finding that electron. Hopefully you can see where that is. That's that dip in that graph. That's in between the n value of those orbitals. And here it is again, and here it is again in this one. So we have nodes, that is a 0% probability of finding the electron in between orbitals. Okay? Hopefully that worked well for you. So I got more like a helmet here for you. Ground control to Major Tom. Can you hear me? Give me a thumbs up if you like that video. Give me a thumbs up if you like the hat. And subscribe to my YouTube channel because my hats are super cool. So I will see you next time, or maybe you'll be a NASA scientist and a rocket scientist. I hope you are. See you next time. Bye now.